Welcome again, Michael Wickerson here. We've moved through the ribbon components of vanilla Grasshopper through the params, the maths, the sets, and we're now going to enter into the vector tab. And I'm going to skip over the field operations because I think they're fairly particular to a couple of online tutorials that have captured my interest, but I think I'll leave it for this level of course. Let's jump into the grid and what actually is happening within there. It's pretty exciting grid nodes that are available to here, and as we start to consider populating geometries as well. What I've done is I've gone in and said, okay, well let's have a look at a grid, and I have it in artistic mode, and I think shaded would be fine. Basically, a grid set up as a rectangular grid, a hexagon grid, a square grid, and a radial grid, and a triangular grid. You should be able to customize and make your own. There's a few online tutorials that are very good at that, but this should be enough to start. What I do like is you get trees of data out. So we'll stay focused on the hexagonal grid and see that we have a set of cells, and I put a bounding box around those sets of cells. And that, I think, defaults to a union box, which means it will involve all of those cells. You can take off the union box and see how that changes. Feel free to run in any of these other ones, but be careful because my final form is fairly three-dimensional and uses some solid difference, and it takes about 5 seconds to wait for the script to run. If you make the mistake and jazz this number up to what I had set as 10, it makes those iterations a lot larger, and you can be waiting up to a minute for each time you want to run your script. A nice technique is to hit your middle scroll key and lock the solver when you do change things, and then open it when you're done. What I've done with that bounding box is I brought it all the way over here to a surface to split. But what did I split it with? Well, I split it with something fairly simple. Taking those geometries, I extruded them, and I produced a volumes or extrusions that actually could produce additional bounding boxes, and populating those bounding boxes from these number sliders. 3 in each case is a count. So I populated these and I populated these. I dispatched them by taking certain amounts of the list that come in and put them in this direction. I get 25, and over here I end up at 25. So I'm actually calling out a few as I go. And then the dispatch, I'm taking both the vertices, just showing how a dispatch works within that 3D geometry. And I've drawn lines and closed them. So I have these circular forms or closed forms, and I have these linear forms, and I can split the surface with those linear forms if I wanted to, but I thought it would be more interesting to close them up with the periodic set to true and split that surface, so I end up with these kind of donut forms that can be used to Boolean difference the original box with those forms that were coming through the pipe, and that's what slows down. So once you've generated that, you end up with this kind of structure, kind of hollows of looking through. It becomes fairly complex as you go, and if you want a nice piece of geometry representing a very strange environmental building or tower, all you have to do is lock that solver and possibly go up here and change this count to something a little higher, like 10. You don't want to go much higher than that, because I think this is about a minute iteration. If I was to take all of these and jam them into there, I'd have a much higher count for a final geometry. What we can do is take a look at this geometry and realize what happens when we control shift this back to the cells in a square case. What do we end up having? And I think that's a 5-second count. I'm waiting patiently, and hopefully I don't crash my computer out. I'm very wary with my data structures and what I'm looking at in Grasshopper, so I don't ask the computer to do too much. The hexagon cells were working nicely. The rectangular cells, oh, I did have it set to a higher size of 10 and 10. Let's see what geometry we get. We totally end up with something taking a bite out of the sides and doing something different with a 22-second script, which makes me think that anything square or rectangular is going to take a long time. I am interested just to take a chance on putting the cells down into the triangular grid pattern and seeing what geometries I come up with. Well, you can see you have the little floating bits lying around. So we could be waiting here for anywhere up to a minute, but I think it'll be somewhere between the 5, considering hexagon grid. And you could tell that it actually set itself up to not do too much in producing strange geometries as I look at it. So I definitely think the one of choice set at that setting, playing through the picking up grid forms would possibly be the hexagon cell at 5 seconds, and that should run fairly quickly and bring us back to this. What I do ask in the end is consider what you could do by populating geometries. Here's a cylinder, and starting to populate geometries in different shapes with populating 3D, and then if we look down upon the top, you'll see it's hollow. We can also use the populate geometry, which makes all the points appear throughout the entire volume. Thanks very much for watching. We're going to keep moving right on and go into deconstructing the plane and seeing what we can pull out and find some useful components within the vector tab. I am happy to say we made it through the tree section of the sets tab. There's a lot of complexities there. I visited the path mapper about 3 times in these scripts. I think we will get moving once we master and have a look at 20% of the nodes and get a good feel for the math sets and vectors. Curves all the way through display should move pretty fast in this series. Once again, when you've found something that you like, I want you to go in, I want you to group it, and set it to the color that's suitable for you, remembering that you have looked at those scripts. There we go. Nice finished form. Thanks for watching 6 minutes.